Now let's consider some different scenarios dealing with inflow, freshwater inflow from rivers and nutrients in the Gulf of Mexico, the Hypoxic Zone or dead zone that they call off the Mississippi River Delta. There are two main influences on that system, the freshwater inflow from the river and the nutrients. So we'll talk about four different inflow nutrient scenarios here. Let's start with a low inflow and low nutrient scenario. Look at this. This is the fresh water. If you've ever seen the Mississippi, you know it's very muddy. So is the Brazos River. Hypoxic zones have also been found in the Gulf off of the Brazos River in Texas. But that river water, it's fresh, it's less dense than the surrounding seawater. It floats on top of it, and it takes a long time for it to mix with the surrounding seawater. Now look at these arrows here. What's happening is that at that freshwater saltwater interface, there's a pycnocline, it's called. It's a large change in density from freshwater to saltwater. Oxygen does not diffuse very well at all past that. So you could think of it like this, that oxygen coming in from the atmosphere, it hits that pycnocline and it bounces off. It doesn't penetrate very well. Slowing the diffusion is probably a better way to describe that. It's just a very slow diffusion across that. But we can think of it as bouncing off just because it's not penetrating as well. Now, what causes hypoxia is that when the oxygen consumption is greater than the oxygen being input into the system, the oxygen concentration decreases in the water. And if it gets below 2 parts per million oxygen concentration in the water, that's what is considered hypoxic. That's when fish and animals, other animals, normally start having problems due to low oxygen levels, and they will start searching out situations that have a higher oxygen concentration. So a situation like this where it's calm, it's cloudy, and low nutrients, that could be a bad situation potentially for creating hypoxia. However, if it's windy and cloudy, or windy and sunny, then hypoxia is probably not going to occur. Calm and cloudy is probably the worst case scenario for any inflow nutrient scenario, especially if it's a sustained period of calmness and cloudiness, because it takes a while for the oxygen to be used in a system. Even though it's cloudy, you'll still have some photosynthesis going on. Even though it's calm, you'll still have some diffusion from the atmosphere. So you'll always have inputs of oxygen. It's just that if the consumption of oxygen is greater than what's being put into the system, and that occurs for several days or weeks, that's when you can run into hypoxia problems. Now let's look at another scenario, low inflow and high nutrients. Again, calm and cloudy is probably the worst situation there, but with the high nutrients, you have more algae in the water. So your net input of oxygen is probably going to be greater than a low nutrient situation of the same calmness and cloudiness. But you'll also have greater consumption of oxygen because you have more things dying, more detritus in the system. Detritus is just dead stuff, dead plants, dead animals. Now if it's sunny, you'll have even more photosynthesis going on. And if it's sunny and windy, you'll probably have plenty of oxygen and hypoxia won't be a problem. Now let's look at a third inflow nutrient scenario, high inflow and low nutrients. If it's windy and sunny, you'll have plenty of oxygen coming in from diffusion. However, this larger amount of fresh water on the surface, that just creates a larger barrier from atmospheric oxygen penetrating down into the seawater. So a windy, sunny day with high inflow, you're going to get less oxygen input from the atmosphere than if it was a windy, sunny day with low inflow. Just think about that. Fresh water, if it was really muddy too, it's going to be a sunlight barrier too, and it's going to prevent photosynthesis. Now you can imagine if there's any nutrients in that fresh water, they will be diffusing out into the surrounding seawater. But underneath that plume, especially where the plume is the freshest, where That's usually where it's the muddiest water too. Underneath that is where it will really affect photosynthesis. Now, cloudy and calm, that's usually the worst scenario within any of these scenarios, because cloudy and calm means less diffusion from the atmosphere, less photosynthesis because there's less sunlight. And then if we add on top of that a very large freshwater barrier, it acts as a source of stabilization to the system, and it really prevents that oxygen coming in from the atmosphere. However, since there's low nutrients in the water, a lot of times that means there's less things dying, so there's less oxygen consumption in the sediment, so it's not as big of a problem as if there were high nutrients. But again, sustained over a period of several days, then this is a much worse scenario for the creation of hypoxia than a low inflow, low nutrient situation. And this is what happened on the Brazos River in 2007. This is basically the situation there. In 2007 in the summer, the Brazos, when compared to the Mississippi River anyway, it's a fairly low nutrient river, but there was a sustained high inflow for almost the whole month of June and July. And a hypoxic zone, fairly large, up to 1,000 square miles, was reported off the Brazos Delta. Well, let's look at our fourth scenario, which is probably, if there's going to be hypoxia, it's going to occur in a high inflow, high nutrient situation. That's probably your most likely situation for this. Now, if you have windy, sunny conditions, it's probably not going to be as big a problem. You do have this large freshwater barrier to oxygen from the atmosphere. But if you have lots of wind, you have lots of mixing and much greater diffusion rates than if it was calm. Calm weather is just not as good for atmospheric diffusion of oxygen. And while you will have diffusion of nutrients, if this is high nutrient fresh water like is typically the case in the Mississippi River, you'll have diffusion of that into the surrounding water, which will enhance photosynthesis. But if you had a sustained period of calm, sunny weather with high inflow, high nutrients, the nutrients aren't going to diffuse as well, again, just because there's not as much mixing going on. That large amount of muddy fresh water is going to create a barrier to sunlight, so you won't get much photosynthesis underneath it. Lots of oxygen consumption going on, though, and so that could be a situation for hypoxia. And then probably the absolute worst case scenario is a sustained period of calm, cloudy weather, high nutrients, high inflow, and you've got a high rate of oxygen consumption in the sediments because of previous growth, even though it's been calm and cloudy, let's say for 2 weeks. Before that, maybe it was lots of sunlight, so you had lots of oxygen production from photosynthesis, lots of growth going on. So then you get this sustained period of calm, cloudy weather, all these organisms start dying, and that is your worst case scenario for hypoxia. And that is all for this lesson.